Okay, the trig portion of the test and the Pythagorean Theorem. So triangles, special triangles. Here we go. First thing we went over is if I give you 3 lengths, can you make a triangle, yes or no? If you can, what type of a triangle is it going to make? So if you take the biggest number, I always identify the largest number. And these ones, they're easy because they're all in order. So if you put this bottom one down, 21, and you've got a length coming off that's 7 and a length coming off that's 15, the question is, will they swing in and touch, or will they just fall down and land on the base? So you take the 2 smaller ones, 15 and 7, and you add them up, and that's going to be 22. So they will touch. They'll touch somewhere like right there. So as long as they add and give you a number that's bigger than the biggest, you can make a triangle. So now the question is, what type of triangle is it going to make? So you kind of use the Pythagorean Theorem. The 2 little ones, a squared plus b squared, will equal the big one squared. So I'm going to take 7 squared plus 15 squared, and I'm going to see if it's equal to the big one squared. I guess it's 21 squared, or if they're less than the big one squared, or if they're greater than the big one squared. So 7 squared plus 15 squared gives me 274, and then 21 squared is 441. And since this one is bigger, it's got to be obtuse. Okay, the next one. 10 plus 12 is 22. 22 is smaller than 23, so this won't even work. You cannot make a triangle. Third one, 20 plus 4.5 is 24.5. That's greater than 20, so yes, you can. So 4.5 squared plus 20 squared, let's see how that ranks up to 20.5 squared. Okay, these two give you 420.25, and then 20.5, whoops, let me go back. 20.5 squared is 420.25. These are equal, so it's a 90-degree triangle, a right triangle. And then this one, if you do 4.2 plus 6.4, we're gonna get 10.6, and 10.6 is bigger than 7.6, so yes, it will make a triangle. And now let's do the little one squared plus the little one squared, and let's see how that ranks up to the big one squared. So that is 58.6 and 7.6 squared. That's going to be 57.76. So now the little ones are bigger than the big one, so that happens only on an acute triangle. Okay, now you've got to draw your own picture from this context. So Xavier cannot walk from point A to point B because there's a pond in the way. So it doesn't really matter. If I put point A here and point B here, he can't walk because there's some kind of a pond in the way. So he needs to get across the pond. Instead, he starts walking by, so I'm going to draw kind of an imaginary direct straight shot path there. That's where he wants to go. That's the shortest distance between 2 points is just a straight shot. So instead he turns and goes 30 degrees from the path. So you can either go this way or you can go this way, it doesn't matter. But I'm going to go off 30 degrees. So that's a 30-degree angle right here, inside here. And then he turns 90. Okay, I think my picture's wrong. Because the 90's got to be right here. So 90's got to be right there. He turns 90, finally walks 40 feet. So my 90's got to be right there. The 40 feet's got to be right here. So from A to B, here's got to be my A right here. So A to B's got to be the hypotenuse. And I was drawing A to B, so 30 degrees right there. I was drawing this. I was trying to make the 90 right there, and I was trying to make this the hypotenuse, but that's not the case. So make sure you kind of read through it twice and make sure everything matches up. So this is what got me right here. If he makes a 90-degree turn, so instead of walking, so there's got to be a pond right here from A to B blocking his path. So instead of going here, he turns 30 degrees and walks, and then he turns 90, so the 90's got to be right here. And finally he walks 40 feet to reach his destination. So from that turn, 40's right there. So your picture has to look like this, or it could be reflected. It could look like this. Here's the A, the B's over here, so there's my 90, there's the 40, and he can't go from A to B. But that's what we want to find. If he were able to take the straight shot, how far would he have to walk? And so since this is a 30, this is a special triangle, 30, 60, 90, so it's going to be a piece of cake. So your other half of the triangle is right here. And if that's 40, that's 40 also, that's 80, and that's 80. So the straight shot from A to B has got to be 80 feet. So the hard part is just getting the picture set up correct. Okay, this one right here, the sine from phi is 3/5. Now this looks like theta, but it's not. Theta is this one and phi is this one. So the sine, your position is right here. Your position's from phi. So sine is opposite over hypotenuse. We need a 90-degree triangle, so we're going to have to kind of make one. We're going to have to go across here. And make our own triangle. So phi's right here. The opposite's going to be this piece. The hypotenuse is going to be this piece. And then my adjacent is right here. So the sine is 3/5. And 3/5, 3 is the opposite, and 5 is the hypotenuse. So they're giving me some lengths of this triangle. So the opposite is 3, and the hypotenuse is 5. So if this piece is 3, this piece is 3, and this piece is also 3. So what they want us to find, they want us to look from a different position. They want us to look from theta. So look down here from theta and find the cosine of theta, and the cosine is adjacent over hypotenuse. So from theta, this is the adjacent and this is the hypotenuse. So the cosine would be also 3/5. But the question we'll ask on the test is what we should change this to is what is the sine of theta? And the sine of theta, they need the opposite, so they need this piece right here. And you should recognize this is a Pythagorean triple. 3, this would be 4, and the hypotenuse is 5. So the sine would actually be 4/5. And if you don't recognize that as a Pythagorean triple, just do the Pythagorean theorem, a squared plus b squared is c squared, and you'll get it. Okay, number 12. We got a drag and drop. So for instance, if you drag and drop cosine of A, cosine of A is equal to, it's not equal to the cosine of B or the cosine of C. Cosine of A is going to be this piece right here. There's my 90. C is the 90. Cosine is going to be this piece over this piece. and that is the same thing as the sine from B. Because if you're going sine from B, sine is the opposite over the hypotenuse. So the cosine from A is going to ask you to look at the same two pieces as the sine of B. And the cosine of B is going to ask you to look at CB. So the cosine of B is asking you to look at little a and little c. And the sine of A also asks you to look at little a and little c. Okay, the next one. Katie and Matt are flying kites on a breezy day. The string of Katie's kite is extended 864 feet, and her kite makes a 38-degree angle of elevation with the ground, not with her hand. So that's important. So Katie, here's Katie. Her string is going off. Her string is 864. The angle of elevation, so that's the line of sight. So the angle of elevation, you just go horizontal, is 38 degrees. So now I'm going to draw from her kite perpendicular. There's my 90. And this is what we want to find. You want to find how tall is that kite off the ground. So this is Katie. Matt's kite, his string is 725, and his angle elevation is a little steeper. His angle is 40 degrees. So I'm going to come straight down. There's a 90. This is what we want to find. Round your answer to the nearest foot. Let's see whose kite is taller. So Katie's got more string but less of an angle. Matt's on a steeper angle, less string. Which one is higher off the ground? So from 38, this is the opposite and this is the hypotenuse. So we got to use sine. So the trig I'm going to use is sine. I'm going to do sine from the 38 degrees, and the fraction is x over 864. And then for maths it's the exact same thing. Sine from the 40 degrees equals x over 725. Okay, now I'm going to solve for x. So just undo that division. Times both sides by 864. Times this side by 864. Times this side by 725. Times this side by 725. And then calculator from here. So 864 times the sine of 38. Okay, rounded to the nearest foot. Katie's is 532 feet off the ground. Matt's 725 times the sine of 40. His is 466 feet. So Katie's is higher. Okay, find angle A. So let's make a triangle. Let's draw perpendicular from B to C. There's a 90. This triangle is 1, 2, 3. This is 4 units along the bottom. 1, 2, 3, 4, 5 units along the top. If you're going from angle A, the 5 would be the opposite piece, and the 4 would be the adjacent. So the trig I need to use is tangent. And the tangent from angle A, you always got to tell me what position you're going from, is equal to 5 over 4. Now if I have the entire fraction but I don't know the angle, I need to solve for A. I need to undo this tangent. So I do the inverse tangent on both sides, and this is what I type into my calculator. Inverse tangent of 5 divided by 4, and that's going to give me angle A is equal to 51.3 degrees. So remember, you've got to use the inverse tangent if you're ever going to find degree. Okay, this one we've got to draw a picture. So Eric's in an airplane. So maybe some airplane. Here he is right here up in the sky. He sees his house. Here's his house. And the line of sight is from here to, we'll say he's looking at the bottom of his house. So we'll say the line of sight is from here to the ground instead of the roof to his house. Okay, there's his line of sight. He sees his house on the ground at 45 degrees angle of depression. So the line of sight, I've got to go, I keep going straight across from the eyeballs, and now I'm going to turn and make a 90 degree. So there's my 90, and this is the angle of depression, 45 right here. Okay, his altitude, he's 2,200 feet. That's this piece, 2,200 feet above the ground. What is his horizontal distance from the house? So how far is this piece right here? And because this is a 45, 45, 90, I know it's half of a square, and I know all these pieces are the same, 2,200, 2,200, 2,200. If they want the hypotenuse, the line of sight, it's just 2,200 multiplied by the square root of 2. Okay, another one, we're going to draw a picture. So Lewis is standing on a street in New York City. He's looking at the top of the Empire State Building. He's looking up with a 30-degree angle of elevation, but that's from the ground. So here's the Empire State Building. Here's Lewis. So he's looking up from at a 30-degree angle of elevation, but that's from the ground. That's not from his eyeballs. That's from the ground. So now I go over horizontally. So my 30 degrees is right here. He is 767 meters from the Empire State Building. So this piece is 767.6. How tall is the Empire State Building? So instead of using trig, I'm going to use your special right triangles. This is a 30, that's a 60. So my other half is right here, so it's a 60, 60, 60. And they gave me the middle. And they want this piece right here. So to go from the middle to the short piece, you just take the middle, 767.6, and you divide it by square root of 3. So do that on your calculator, and that will give you the height. And that Empire State Building is 443.2 meters tall. Okay, next question. The picture is drawn for you. This is a proposed wheelchair ramp, so it's got to be made with a 4.5 degree angle of elevation. What's the rise? So this piece right here. So from that angle, this piece is the opposite, and 180 inches is the adjacent. So we got to use tangent, because tangent uses opposite and adjacent. So tangent of 4.5 degrees equals the opposite over the adjacent. So undo the division, multiply by 180, multiply by 180. So 180 times the tangent of 4.5. And that rise is 14.17 inches. Round to the nearest inch, it's about 14 inches. Okay, this image, these are all squares, and that's a 90-degree triangle. So the perimeter of square 2 is 200. The perimeter is the pieces all the way around. So that means they are 50 by 50 by 50 by 50. So that'll give us 200. The perimeter of square number 1 is 150, so let's do 150 divided by 4. 150 divided by 4, that means these ones, it's a 37.5 by 37.5. Okay, square 3, he wants to know the perimeter of square 3. So it's a what by what by what by what, add them all up. So I gotta use Pythagorean's theorem. I'm gonna use this triangle right here. I know the height of this triangle is 50, and I know the base of it is 37.5. So I'm going to use that to figure out the hypotenuse. So I need the hypotenuse, so it's going to be 50 squared plus 37.5 squared equals x squared. So I get 3,906.25 equals x squared. So now I square root that. And my hypotenuse is 62.5. So that means this square is 62.5 all the way around. So if I want the perimeter, I'm just going to do 62.5, multiply that by 4. And that should give me the perimeter. The perimeter is 250 units for square number 3. Okay, this trapezoid, they want the perimeter, so we're going to add up all these lengths. That piece is 10, so that piece is 10. Now, this 30, 60, 90, here we go. I'm going to flip it. There's the other half of it. That's 12. So I know that x is 6. And I know that z is 6 square roots of 3. So if that's 6, this is 6, and this is 6. Because this over here is a 45, 45. So that's half of a square. And I know this is 6 square roots of 2. So now the perimeter, I'm going to start right here. Take 10 plus 12 plus 6 square roots of 3 plus 10 plus 6 plus 6 square roots of 2. So my like terms are 10, 12, 10, and 6. So 10 and 10 is 20. Plus 12 is 32, plus 6 is 38. So 38 plus 6 square roots of 3 plus 6 square roots of 2 is my perimeter. These are not like terms, so we can't add them up. And then x, y, and z. X is 6, y is 10, z is 6 square roots of 3. Alright, each triangle is a 45, 45, 90. Find x. So we got to work backwards from here. So if this is 6 and these are all 45, this is half of a square right here. But they gave me the middle. To go from the middle to the edges, I need to do 6 divided by square root of 2 times square root of 2 times square root of 2. So it's 6 square roots of 2 over 2. That's going to divide, so it's really 3 square roots of 2. So this piece is 3 square roots of 2, and what I should do is blow that up. So 3 square roots of 2, gotta remember that piece is 3 square roots of 2. So that's 3 square roots of 2. This one is 3 square roots of 2, and that again, here's my square, so this is the middle. So I gotta take 3 square roots of 2 and divide by square root of 2. So that means this piece is 3 and this piece is 3. So now I take this, which is the middle of my square right here, divide that by square root of 2 times by square root of 2 times by square root of 2. So it's 3 square roots of 2 over 2. So this piece is 3 square roots of 2 over 2. This piece is 3 square roots of 2 over 2. So take the middle, 3 square roots of 2 over 2, and divide it by square root of 2. So that's the same as multiplying by the reciprocal, multiplying by 1 over square root of 2. So this square root of 2 cancels this square root of 2, and your answer, x, is just 3 halves. Yeah, we got the answer right there, so it is 3 halves. Okay, the next one, I'm going to draw our own picture. If the length of the longer leg in a 30, 60, 90 Okay, 30, 60, 90 comes from a 60, 60, 60. So I just cut it in half. So there's my 30 and there's my 60. So the longer leg is the altitude. It's across from the larger angle. The bigger angles give you bigger sides. So this is 5 square roots of 3. What is the length of the shorter leg? So it wants this. So I'm going to take the middle, the long leg, 5 square roots of 3, and to go backwards you divide by square root of 3, so those cancel. So that means this is 5. So that means this triangle is a 10 by 10 by 10. Okay, these last ones. Find the value of the trig indicated. Find tangent of theta if the sine of theta is 15/17. So draw your own triangle. Put the 90 somewhere. I'm going to put theta right here. If I put theta here, that means this is the opposite, this is the adjacent, and this is the hypotenuse. So they're telling me the sine from this position is 15/17. 15 is my opposite, 17 is my hypotenuse. So 15 goes here. My hypotenuse is 17. And they want the tangent. Tangent, the fraction for tangent is opposite over adjacent. And I know the opposite, but I do not know the adjacent, so I gotta find it. But I can use Pythagorean's theorem. Pythagorean's theorem says take the two small legs and square them and add them. So x squared plus 15 squared, and that's going to equal the hypotenuse squared, 17 squared. So it's really x is equal to the square root of 17 squared minus 15 squared. So if I do that, I get lucky. This is a Pythagorean triple. So this is 8, 15, and 17. And then opposite over adjacent, your answer should be 15/8. Okay, the next one, secant. Secant is hypotenuse over adjacent. Cosecant is hypotenuse over opposite. So if I draw a triangle, they gave me the, I'm going to put theta right here. The hypotenuse would be 5 and the opposite would be 3. And this is a Pythagorean triple, this is 4. And they want hypotenuse over adjacent, so they want 5/4. Okay, these bottom two, you got to draw your own triangle. And the C's got to be a right angle, so there's your 90 right there. So it doesn't matter where A and B are. But they're going to tell you the measure of angle B is 54 degrees. So B is 54 right here. And then little b is 5.5. So little b is this side right here, 5.5 across from angle B. So here's what we got to find. We got to find angle A, angle B, angle C, side A, side B, side C. So C is 90, B is 54, and that means A has got to be 36, because 36 and 54 are complementary. So little b is 5.5. I'm going to choose, let's go from A. If we go from A, the opposite is going to be this piece, the hypotenuse is going to be this piece, the adjacent is going to be this piece. So I'm going to use this piece and this piece. I'm going to find little a first. So opposite and adjacent, you got to use tangent. So tangent from 36 is going to equal opposite over 5.5. So times by 5.5 times this side by 5.5, and you get 5.5 times the tangent of 36. This opposite, if we're just rounded to the nearest tenth, it's going to round up to a 4. This is 3.9959. So now little a is 4, and if you want to find little c, you can just do Pythagorean Theorem. 5.5 squared plus 4 squared is going to equal the c squared, so take the square root of whatever that is. Square root of 5.5 squared plus 4 squared, and you should get little c is going to be 6.8. Okay, and the same thing for this last one. Draw your own triangle. Make C be the 90. So this time we'll put A here and B here. So A is 42. That means B's got to be 48. And little c is 3. So I'm going to go from A. If I go from A, that's the opposite, and that's the adjacent, and that's the hypotenuse. So let's use sine. The sine from 42 degrees equals opposite over hypotenuse. So times by 3 times by 3. 3 times sine of 42. So that means this has got to be 2. And then if I want to find this side right here, I just do the square root of 3 squared minus 2 squared. And that's square root of 9 minus 4, so it's just square root of 5. So this is square root of 5, but I guess decimal square root of 5, whoa, is 2.2. So this side's going to be 2.2.